If you want to start with that, then we can take a look. So Vinny's been working on the planner for the Ross Lawn Tractor, upgrading it to Move Base Flex. And he's got a pull request out there now, and this is the review of the project that he's been working on.
So, I mean, basically the main things that have changed is the launch file. Um, Instead of MoveBase, we're using MoveBase Flex. And that's like a very standard sudo apt-get install for MoveBase Flex. And I was able to plug in the local TB local planner just like before. Another change I had to make to get it MoveBase Flex compatible was implement a SMOC state machine. And this is, very simple. It's very similar to the tutorial, but there's a get path state, there's an execute path state, and a recover state. And this kind of goes through that, like a wait for goal, and then it switches to it's basically it switches to get path, to wait for goal, and execute path. And I don't actually fully understand the details and the syntax of what's going on, but it works.
That's the main thing, right?
Yeah, but yeah, maybe I thought I was prepared to talk about it, but I guess I'm not.
So you're using MoveBase Flex to pass in, I mean, you're using Smash to pass in the path to the action server of MoveBase Flex.
Yes. Yes. Also, why does it take like about 17 seconds for everything to load up? Is that a stage limitation?
Stage should, I don't know. It's a really good question. It does delay. There is sort of a delay, and I didn't know if it was, I don't know, the robot model or if there's some other thing that takes time to load.
Okay. But yeah, this is the sim as you guys probably know. I can send it a goal. And then if you guys look at my terminal on the bottom, I'm pointing to it.
Yeah.
But basically it'll say start action, execute path using controller. And then once the tractor hits its goal, it transitions from execute path to wait for goal. And then I give it another goal.
So where is that goal being sent to? That's the goal is Smash listening for that goal?
So let's look at the, yeah, I think so. It is listening for that goal because it's monitoring the state of that topic, MoveBase simple goal. And then I can show you the RQT graph.
That's really cool. And then, so when you pass in that goal, where, how does the plan gets generated on how to get to where you want to go?
So it gets the goal, it outputs it to execute path, which I can't see the syntax of where it's doing that.
Okay. So
goal callback right here.
Yep.
And then it's passing it to execute path, I believe. And yikes, this is huge. But I'm trying to look for SMOC in here. Or do you call it Smash?
Sometimes I don't. I'm not sure. It's like Linux or Linux or GIF and GIF.
I think the people that wrote that said it should be pronounced smash, which
Oh, it should be pronounced smash? Okay.
which it doesn't look like that to me, but that's what they claimed.
So it looks like
Tomato,
everything's
tomato.
happening through the action server, not necessarily the topics, because you can't see it on RQT graph.
Okay, but like, so that simple goal is a XY yaw. And then when you send in the execute path to move base flex, it's looking for a path, a nav message path. And I was wondering how the goal gets switched over to a nav message path.
Yeah, that's a good question. That's a lapse in my understanding.
There's a lot of stuff going on here, Vinny.
Yeah, that's a good question, because yeah, you've got me.
Okay, well, we can learn it's working. So obviously it's happening somewhere.
It's happening, and I mean, honestly, this whole state machine was copied and pasted.
Yep,
But yeah, it is important to know what's actually going on.
that's really cool. I was wondering, just kind of following through, what's a way to kind of step through the whole thing? Like you sent, that was cool. In RViz, you draw on the map, which gives the XY yaw to move base simple goal.
Mm-hmm.
And then it gets path, and then you send that to move base flex under the execute command.
Yes.
And then Teb drives you on that path.
Yes.
Okay. Trying to understand it a little bit. It's going to take a little while to work through this.
No, it is. I should have prepared slides or something and should have understood.
No way.
Yeah. But yeah, honestly, I'm unclear what is going on inside the state machine, other than it works. So sorry about that, guys.
I was wondering, if you had a pre-planned path, how do you interface to that?
So I think it's through, I didn't implement this yet. But I think it has to do with sending something to this action state. And that's what I was playing around with before my hybrid A-star. I realized that wasn't working. But there's a place here where you can it's not in the state machine, but I'm assuming it's going to be through the execute path action.
Okay. That's good. There's a lot. It's a lot there.
Yeah. If you want, I can try to drill down on what the state machine's doing, and be ready to talk about it next time.
Okay. Have you seen? I think it's called FlexB.
What is it called? Flex what?
FlexB. That's kind of where people, I guess maybe a couple of years ago, stopped using Smash and they're going to FlexB.
Speed.
FlexB. I mean, I'll post it.
Okay.
It's also a state machine.
Oh, Flex B.
It's the same thing as Smash, but has sort of like a GUI interface and some other features. That's kind of where the development moved to, I think.
There's a GUI for Smash. I've seen it.
Okay.
Like in RQTs. Um, oh, it's called Smash Viewer. Let me see if I can get it loaded. All right, I'll share again. So this is Smash Viewer, and
Okay. Very
this
nice.
is actually describing the states. And let me see if I can send the goal and then have you see what it's doing. So it's executing path.
That's cool.
And then it goes to wait for goal.
Yep.
So these are the transitions. That's the answer to your question. But yeah, I don't know what it is looking like in code, but it obviously exists.
There's something that happens right before exe path. Oh, you know what we could do for fun? If you want to, you can do ROS topic info, and then on the move base simple goal, and it will tell you who's subscribing to that.
Oh, really?
Yep. Somebody is subscribing to that message. In RViz, when you send in the 2D nav goal, it gets published to move base simple goal. I think that's where it was going.
So yeah, it says publisher is TractorViz and subscriber is the state machine.
Okay, so in that node, the move base flex state machine,
Uh-huh.
we can see there's a subscriber node in there that is subscribed to this topic. So we can follow it that way. You can see the callback.
So
If you do a search in there for move base simple goal, right there, that one.
yeah, so it's doing monitor state on that,
Okay.
and then it's saying goal callback, goal CB. But then if I control F for that, I see recovery path goal CB.
It was above you. It was one above. So you can loop if you're going down, keep going down, and then go back to the top. That one. So user data message. So user data goal. Okay. Somewhere that user data.
Oh, and then I can search for where user data goal is, or yeah, where user data goal is being used.
User data is being passed.
Oh, it's just this.
Okay. I don't understand. I guess I don't understand it. I don't understand, but maybe move base flex. Oh, I don't know. That's interesting. I guess I'm thinking of move base, not move base flex, and so it's a little bit different. I just didn't understand how it knew where to go get there. But that move base simple goal must be like move basic, where basically it just takes the two coordinates and then drives you straight there. It's not doing any path planning or anything. It just takes where you are, where the robot is, where you want to go, the X, Y, yaw, and then just drives you straight there. So
Well, that's, I mean, we're going through the local planner. We are getting we're not getting a straight there movement.
Okay.
Um, like there is curving and stuff of the vehicle.
Okay, so that's cool. That's neat. Is it Teb that's doing that then?
Yeah, it's Teb.
Okay. Well, that's
I just
fascinating.
don't understand how it's going to Teb.
I don't know. And then, and it's also listening to the cost map.
It is, yeah. But that's using the generic global planner. So in MoveBase Flex Space, a local planner is called a controller. Fun
Okay.
fact that confused me for a while. But here, this is where I'm defining use Teb. And then for planner, it's using the generic global planner.
Okay. So in RViz, we could plot the global planner path and the local planner path. So it is using that global planner, and then Teb is, if you back in RViz, if you show those two paths, like can go to add by topic, and then there'll be a global planner.
Global planner path.
Yeah.
And then I'll also add the local planner path.
That's funny.
I'll make the global plan this ugly color. All right, let's see what goes on. Can you guys see that on the screen share all right?
Yep. Okay. That's really cool.
So one fault of this state machine is I can't give it another goal in the middle of it doing an action.
You have to like cancel it and then send in a new one.
Yeah, you can't send it a new one. I'm sure that, can be done with a little bit of thought.
So when it's driving into the side of the house, you have to watch it hit first before you can change it, right?
Yeah, exactly. Let's see if it'll do that. I don't know if it'll get stuck on the wall.
Yeah, if you have some, yeah, look at that.
I don't know how close I can get to the wall with it freaking out.
I mean, won't the local planner drive a path around it, or will the global planner, will it draw a line through that obstacle and see if it will plan around it?
Let's try. I think the recovery behavior is not very well defined right now. Yeah, I got stuck.
Okay.
And if you look at the terminal, oh, it didn't yell that it's stuck. So I don't know what happened there.
Like part of the problem is that the tractor footprint is smaller than the, well, I guess it would still hook on the side there, huh? I don't know what's going on.
Yeah.
But it's a fun test.
Not a perfect demo. Not a spectacular shiny apple demo, but
it works.
it worked. We just don't know why.
No, there's a global planner there. That's a hoot. Thanks for doing that, Vinny. That's a ton of work.
Well, thanks.
Or you may take the robot out tomorrow and try to do a demo with that with a real vehicle.
Okay. Let me know how it goes, and be aware about that goal behavior. That it's not. It won't take in another goal.
It's really interesting. Move-based Flex has a cancel. So if you send in a cancel message, does it stop executing at that point?
Probably. I'm not sure how to manually send it the cancel message
Okay.
because it's everything.
It's a service call.
Sorry.
It's a service call, but we can play around with that. I guess on my robot, when I telly up it around, I have that button mapped to cancel. So if I send it a goal and something's running into the house, like Alan says, then you can push that button and then cancel the goal. But being able to cancel a mission is pretty important.
Of course.
Chasing after it, running down, e-stop.
Yeah.
It looks like Jeff is ready to test your move-based Flex also. He's got his robot outside. Your mute's
You're
on.
on mute.
Yeah, you might think so.
Oh, that's great, Vinny. That'll be really cool. So you saw on the global path how the global path goes like this and then goes like that, where the Ackerman vehicle can't turn like that.
Sure.
So it'd be neat to get a global planner that has those nice curves and get you around things.
Sure. No, I think I understand the need. It is just a very difficult implementation.
Simple. No. Awesome. Thanks for doing the review. We'll get that checked in and we can start playing around with that.
Yeah. Thanks.
Alan, did you make any progress this week? Nope. Hi, Soen. Good to see you. Are you staying safe out there in Chicago?
Hey Matt, can you hear me?
Yes.
Oh, cool. How are you? It's been a while.
Yeah. How are the projects?
Things are okay in Chicago. I'm just locked inside, so you know, keeping on. Just I continue to work online, but it doesn't really matter for me. I can work from anywhere, so.
It's good. Glad you're staying healthy.
Thank you. Yeah.
John Lee, are you driving your little robot around yet? Your Raspberry Pi car?
Hey, Matt, I did not get the keys yet.
Oh, okay.
So, did you get yours?
Oh, yeah. You want to see it? I'll give you a
Really?
demo. This is the Speed Racer. Oh, wait. I have to find the Speed Racer.
So, which company you get it from?
Both, but I've been using the one from the UK. I'll show you which one. This one right here. And this goes.
Hey Matt, was that the video that you put on the Slack with the
Yes.
That was pretty
What do
cool.
you- What do you think of this little robot?
Cool.
And then this is the little robot doing autonomous missions. You want to see him drive an autonomous mission? Okay, you can't
Cool.
see the little robot because I covered it up with a fiducial marker, but that's a sacrifice. And now that I have move base flex, I can send it a pre-planned path and have it do area coverage.
Mm.
My transforms are off, my maps are off, things are still not correct yet, but it can drive an autonomous mission. It'll please the investors.
Mm.
So did you say it'll cover an area now, or area coverage? How'd you describe that?
Yeah, with Vinny's changes, what the work that he added to the project will allow us to send in like if you have a path that you want it to drive, you don't want the global planner to try to figure out how to maneuver around obstacles. You just want it to go down a specific path. With Move Base Flex, you can just send Move Base Flex that path, kind of like, so you have a global planner and you have your local planner. And in Move Base, you can't just inject a path. You always have to go through the global planner. And with Move Base Flex, they allow you to go directly to your local planner. So you don't need a global plan because I've already have my area coverage figured out, and now I want to send it in.
Oh, very good. So you send that in as a text file or something like that with here are the waypoints you want to go to?
Publish your nav path to a topic. It's /plan is the topic, but you can
Okay.
change whatever topic you want. But
So the
what did you think of the little autonomous mission from the $20 robot?
yeah, that's very cool. Like, can you like let's say if you have a field to cover, can you continuously send the GPS waypoint to like define this kind of path or the area coverage you want to perform?
Sure. It's usually all done at once. The planner calculates that and then sends back a path, not necessarily a GPS coordinate. So but you can think of it that way, just different terms. There's a lot to learn, John. I'm just baby steps and then work your way through. Like path planning is a couple years away. Vinny, how long have you been using ROS?
4 years.
Oh, really? But people still did not figure it out, like about this kind of path planning, interface. We don't have a user interface for that.
There's
Like
not
the
a lot of nuance.
web app. Like you can define from the web interface, right? Web, like a map.
Yeah, think of that as like RViz, like Vinny was doing. You click, that's like waypoint. It's called a goal, but same thing.
Oh. Yeah, I was curious why like the logistic is still working in UK because it looks like the slow down everything, like from the shipping, from the watering stuff.
Yep. I don't know.
Mm.
Matt, I know you put the link in the Zoom almost every meeting, but can you send it again? Because now I am interested in building one.
The little car.
Yeah.
Yeah. It's
It's
I know it's very simplistic and not, but it is can learn a lot from it surprisingly.
And I might have most of the parts in my big parts box that I've been carrying around all these years. So
Okay, found the link.
but right now it's very slow. It's hard to get it right now. Special time.
Yep. Yep. Yeah, I think if someone was able to build that robot, do area coverage, do planning, obstacle detection, that would be really useful before starting on a bigger vehicle. You're just gonna, I mean, you can learn it on both, I guess. It doesn't matter, but this one's nice. It runs on your floor and has 4 batteries, so it's easy.
Mm. You mean, Matt, you said you also get the KenGem, like KenGem kit, robot kit as well?
Yeah. Oh yeah.
Recently? Are you talking about now or before?
I got that in December, the CamJam kit.
Okay, okay, yeah, December, that's possible. But right now it's almost impossible.
Yeah, I got that little one that I posted the link for just a week and a half ago, just before.
Really? What's going on?
Do you have a soldering iron, John?
Soldering gun, you mean?
Yep.
Oh, yeah, I can get one. I don't have one yet, but I can like loan somebody's from some place.
Okay, because the CamJam kit was pretty much all together. There was no soldering. You had 6 wires to plug in and then tape to mount the motors. But this little kit that I posted in there, that one, you have to solder all of the motor controller together. There's a lot more work involved.
Oh, okay. Okay. That should be not a big problem. Yeah.
You know, it takes a little bit extra time.
Okay.
And you need a soldering iron, some other gear.
Why just don't solder them together?
Cost.
The cost? Oh,
Yeah.
labor cost. Transfer to the customer.
Yeah. Yeah.
Yeah, I was curious why these parts, I believe they're made in China, you know. So why they don't ship directly from China? Let's say we ordered from the UK company, right? They still could ship it from China. I just don't know why everything need to go to UK. They're running out of stock and then they're slow, you know.
Yep. Just this time.
Yeah. Probably next time we can stock like hundreds or 50 of them in US to make life easy.
Yeah. Have you gone through the Turtlebot tutorials on the ROS Wiki site?
Thought about actually I thought about no. You mean the Turtlebot like the Turtlebot burger some for that like a 3 burger?
If you go through the ROS tutorials, they just have, I don't know.
For the
I
the
said
second
Turtlebot,
generation.
but like the Turtle Sim, I guess, is what they use.
Okay. Yeah, I did load. Actually, I kind of get a Raspberry Pi 4 and then install the what is it called, Ubuntu Core, like for the actually for the ChemGen Robot. I'm going through that
Okay.
kind of the previous steps. Yeah. Before the motor control, I think.
Okay.
Yeah. Probably should work on that. Seems I don't have the kits yet right now.
I think he in that blog post, he posts a link to the ROS tutorials. It's definitely worth going through the beginner tutorials. All of them.
Sure. Sure. Originally, expect to have some hands-on experience with the kids, but yeah. Let's transfer, yeah, to work on that, I think, from now on.
They use a simulator, so you can see things move around in there. But anyone else working on a project or have something they want to go over? Jeff's changing sceneries.
Yeah, the only thing I have for an update is I went outside again and ran my GPS stuff. And let's see if I can bring up the screen one. So assuming you can see my screen here,
Yep.
On the left I have, this is the F9P with no correction. This is actually the version 1.1 board. And on the right hand is the version 1.0 board. And if you look at this, let's see if I zoom, how do I zoom in here? Is 5 meters, and I don't know if that's 5 meters diameter or 5 meters radius, but you can see that it's holding fairly tightly here, and that's so that's 2.5 meters. This would be 1.25 meters. So that's within like 1 meter in 10 minutes is where that's moving, and it's not moving around very fast. And if I look at the other board, this is what the other board is doing, and this is the older version board, and for some reason it's just not as good. And I'm trying to blame that on the fact that they redid the RF section. So it looks like the new boards have a better RF section than the old boards. But in general, this is telling you that over 10 minutes made jumps. I've got video of this, but I couldn't post it because I ran into all kinds of problems on that. And then the other thing, while I had the thing out, I thought, well, what's it doing compared to an old version of GPS? And this one is on the left again is my version 1.1 F9P board. And what's that set to? Let's see, can I zoom in on this? Zoom. Apparently this program I can't zoom in. It looks like this says it's 1 meter. So then let's see, so that's moving around about 1 meter over time. And on the right is just an off-the-shelf cheap GPS. It was a BU 353 board. And this was actually the S3, which is a Surfstar 3 chipset. And the one Matt has might be a version 4, which is a Surfstar 4 chipset. But you can see over here, this is set to 10 meters, and this one already set to 1 meter, which means what I'm getting now is about 10 times better than just an off-the-shelf single band GPS only receiver from several years ago. So that kind of gives you an indication. So this is basically what you get cell phone quality is what this one would be over here. And then the one on the left is the newer dual band F9P receivers that have multi-constellation. So here you can see I'm picking up all these satellites. And on the right, you can see I'm just picking up a handful of GPS satellites. And that's the result you got back, 5 years ago. This is what you would expect out of it. But with the modern stuff over here, so it's about 10 times better than what you would expect a few years ago. And I do have video of this running for like 10 or 15 minutes, but I ran into all kinds of problems trying to load that. The first thing I did was, if I back up to this video, let's see how to zoom out. Where I was running this video out in my front yard, I ran it for like 10 or 15 minutes. And then I attempted to put my computer in standby and take it to the house. I put it on the table, turned it back on. When I got done, I had 3 hours of video that it recorded. So then I pulled up the Windows video editor and attempted to trim it down with that. And that turned it to be a total fiasco. So I had to trim it down. And then you had to say, create new video. So I'd write the video out. So it took another 15 minutes to create the video. And when I was done, I couldn't reload it back into the same program. I said, write it out as MP4. I said import as MP4, and it just would not work. And after about 15 minutes of screwing around, now it just started working. So I don't know what happened there. So some of these Windows tools aren't necessarily the best thing you should be using. So I guess that's pretty much all I have to report, except for my I was playing with that what's called OBS, Open Broadcasting System. That lets me switch multiple microphones, multiple cameras, and I can do the green screen, and I can do the green screen can either be a static image like you're seeing on Zoom right now, or it could be you can put an actual video in the background. And then I ran into problems with the audio again. The first time I ran into audio, and this time when I pull up the different scenes, it's not telling me the right thing. So I need to play with that some more. So I keep working on that, and eventually I'll get to the point where, I can pull up and say, well, here's my intro screen, and then here's a short little video and the picture of me talking with this background, and then switch it to a live background, maybe show my desktop or whatever. So I keep playing with that, and eventually I'll get to the point where maybe it'll be usable. But I guess that's all I got to report right now. That's all I've done. That's all I've done this entire week.
That's a lot. GPSs take time. Are you looking at using dual, like the L1 dual setup, or just playing around now?
Well, my current setup is dual band, so it's got L1, L2, and it's got the multiple constellation, and it theoretically works. I haven't taken the step to, once I get it published as ROS topics, I haven't figured out what to do with the heading data yet. But so that's one of the next steps I got to look at, figure out what to do with that.
Okay, what does that come out over as? Like on the move, you're talking moving baseline or best pause? Is that like a GPS message, like a HDT?
Well, for moving baseline, it publishes the board itself puts out something. It's a UBX, which is a uBlocks binary message called nav rel pos ned, I think is what it's called. And then the ROS node that I'm using puts that out as a topic called the same thing. And if you go look at that, it shows you that it tells you the distance between antennas and the heading in degrees and various other things that it tells you about that. So then it's a matter of figuring out, what do you do with that data once you have it. So I suppose you have to be able to read up the field that says, here's your heading, and then publish that or use that as whatever you want your heading to be. One option would be create a node that says, read that up, and then rewrite it into, rewrite over a field as, you'd expect an ANIMA message or something. So I could just replace the the normal baseline of like in the RMC message or the PVT message, and say replace what it has there and just stick this other number into there. So you could make it work fairly transparently and then feed that into your Kalman filter, that robot localization. That would be one way to do that.
Okay, because Al is working on that, and I'm working on that. So it may be, maybe we could talk about that at some point, about how I'll show you. We've been using the generic GPS driver, the Navsat driver. And inside of here, it doesn't normally publish heading unless you have an HTTP message. But so this is out on the Ross Agriculture GitHub site now. And basically what we've done so far is right here. So this is just added this section here to publish speed. What our speed over ground is. And then from the RMC message, we get this true course, which is degrees from north. And then we make a quaternion, which is heading in Ross, and then publish that over a heading topic. And then right now I'm still working on is like a GPS odometry, where we take the GPS fix message and then the heading message, and then create like odometry and publish odometry between, I don't know if you've made it that far or if you have suggestions or ideas. Maybe there's some ways that we could, okay, so like I always talk about interoperability. And one of the nice things, if we just use a generic GPS, or all GPSs will output a NEMA standard message type. But what do we do in the case of like this U-Blocks, where you want heading, but it comes out on its own, you know, proprietary message or binary message, and not just a standard HDT GGA message, or, you know, NEMA message, I mean.
Well, I guess an answer to that is you have to decide what is Ross going to do with that. If Ross is using that velocity message, which wants a value in, say, forward, or has X velocity and Y velocity, you could create that type of message by using the static heading out of it. Or you have to decide what is Ross doing with it. You know, if Ross is expecting a certain thing, you have to recreate that message, or, you know, wedge some data into that to make that work. And if you're bypassing what Ross is doing, you know, you can make up anything you want to get around that.
Yeah. Yeah.
And that comes back to my statement that I've made multiple times is, you know, Ross wants to do it a certain way, but that may not be the way that you want to do it. So you could work on that and figure out ways to get around that, or to use the additional information that they don't bother to use. So that'd be another way to do that. So you really could take your data and publish a odometry message, you know, create a separate message to do that, and then feed your odometry message into your robot localization filter. So you're creating yet a different message. So it looks like an IMU, but you're feeding it in because you have the information, you have the speed, you have the heading or whatever. So that'd be another way to do that.
Yeah.
And I guess I haven't looked to see what other people are doing out in the world, if they've got a dual antenna system, and you know how they incorporate that into what they're trying to do. So that might be another way to track that down and figure out what to do with it.
I've used the Trimble BX982, which is dual, and it outputs the VTG. There's a message, VTG and HDT both have heading.
But the question is, what does Ross do with that, though?
Well, if it would publish a heading message. If your GPS can output an HDT, it will publish right now, the standard driver will publish a heading message.
Well, then you could just modify the driver to take any extra information and publish a heading topic, and that would match whatever is going on there. Now, does anything use that heading message if you create it? Is this whole robot localization thing, is it set up to handle that?
So that's the good question, and I don't know. Localization is pretty hard. One thought for simple localization is just like we used at the Agbot, is just GPS pose. So basically, it just takes your GPS XY and then whatever you get your heading from, if it's from a GPS or some other place, and then sticks them together. So there's no like sensor fusion or no filtering or any of that type of stuff. Now, what I did at the Agbot challenges, I did that just GPS pose. It's a package on Geodesic Utils. And once I stuck my heading and my GPS together, then I sent it through robot localization, just basically for smoothing, not for sensor fusion. And it seemed to smooth it out.
Yeah, as I was telling Al, what you could do is you could take in, if you had extra heading information, simply substitute that into an existing NEMA message that you have. So you just replace what's there with your static heading. So it's putting out a heading when you're moving, but you can put in a message that's always valid. So that'd be another way around that, assuming that the steps down the line are actually using that information and can do something with that.
Okay. So do we have a Ross agriculture goal for this year, a project goal, or what level should we be at?
You should be a goal where you can have your tractor goes out and plants everything and harvests everything.
So, one question I have, just generally speaking, is you mentioned the TEB local planner is very difficult to tune for real life robots.
Yep.
Why is it so difficult, and why isn't it reflected in the simulator? Like, what are we modeling that makes it difficult?
I don't know. That's a really great question. I'll be more than happy to get the robot out in the field and get you on a Zoom, and then you can control the parameters of TEB.
No, I mean, I believe you. It's not. I'm more asking, like, why? Is it because it's difficult to, like, your motor speed isn't controlled properly, or as accurately as the simulation assumes?
I was going to try to find my notes on that, but basically I just got oscillation times out. And it was like the path that it was trying to drive was not possible to drive with the type of vehicle that I had. And
but in the simulator it works well. So that's like
what. Oh yeah, but that simulator is fake. Okay, you want the real test? The real test is to make the simulator size, the footprint, like the real lawn tractor. Put in the actual dimensions of the lawn tractor into the simulator. So right now, if you look at the simulator, its footprint is very small and it can just turn in place and then drive. But an Ackerman vehicle, your car can't just turn and then drive someplace. It's got to do and back up and do all this weird stuff to get going. But if you change the size of the vehicle, like, and make it real.
Okay.
Yeah.
And I'll see that it's a lot harder
Funner.
just in the simulation.
Yeah. So those are some of the differences between simulation and real. Like you can cheat in simulation, and I totally cheated with that the lawn tractor simulator by that's one way is by shrinking the vehicle size down, which allows it to turn in place, and then widening up a bunch of stuff. So when you get out to the real world, your vehicle parameters are going to be different.
So maybe that's one goal. And I mean, that's why I asked is make the sim as, realistic as feasible, at least from path planning standpoint and interfacing with the GPS standpoint.
Yeah, you brought up a good point about we should take in the GPS data, even though we know the GPS data in the simulator is fake, but we could take in that GPS data and then put it through all of the ROS packages that we use on the real vehicle.
Right.
That's smart. Okay. So we would need to edit the vehicle model, I guess, to start.
For which part? For the footprint part, correct?
Yep.
Yeah. And the GPS part is just a matter of, ROS architecture.
Man, it matters on a lot of stuff. It matters what equipment you have, what grade of equipment that you have. There's so many different ways to set it up. It depends on how accurate you need to be.
So how many vehicles exist within the group? I know you have one, Al has one. Does
Jeff's
Jeff
got
have one?
Mhm.
Is there like somewhere where you have like where everyone has a bill of materials and which one, where are they different? Where are they the same?
For the lawn tractor, we've been kind of keeping track out on the G drive.
Oh, okay. There's a Google Drive. I forgot about that.
Yeah, it's in the lawn tractor folder. And then there's a bill of materials. There's a milestone spreadsheet, and inside of the milestone spreadsheet, there's tabs. And then each of us have a bill of material for each of the lawn tractor. Not up to date and not fully, accurate, but it's a start.
Because I think another thing that you mentioned before is standardizing the interfaces um, between everything, between all the GPSs and everyone's different LiDARs or whatever they're using, cameras.
Standardizing the make it like interoperability. Like most
Yeah.
GPSs output that NEMA message, so it doesn't matter. You can get whatever GPS you want, and our ROS driver will still be able to use your GPS.
Yeah.
Yeah.
Or like standardization of topic names, and I don't know how if you guys are maintaining your own code bases or going off the lawn tractor code base itself, which I can't imagine to be true because you guys have extra stuff.
The lawn tractor sort of is the kind of the project to learn on, and the pieces, the software pieces. We do have different drivers depending on what sensors and motors and things you use, but we're trying to put all that into the lawn tractor sim and the lawn tractor project.
Okay.
That's a lot of fun. That's cool. Good suggestions. Thank you. We're at the top of the hour. everyone stays safe. And is there anything else we need to cover for tonight, or you want to cover? All right. Don't get too bored. Next couple weeks, we can make some robot projects.
All right. Have a safe one, guys. Bye.
Thanks. See you. Great week.
Yeah.
Thanks.